week 2, part 2. Hope you're having a great time. I'm having a good time with this course. Just a quick announcement on something that you probably care about. We wanted this particular term, T3, we wanted to switch back to invigilated final exam. We have heard from you, a lot of you would prefer an invigilated exam. However, the number of students enrolling in this class, it's now double what it used to be last year, up to 800. And so as we were looking at these numbers coming in, maybe a month ago, we were like, well, can we do an invigilated in-person exam? And the more students we saw enrolling, we were scrambling to find rooms to get invigilated the exam and organize all of it. And we needed to see what was the final number to really be able to book the rooms and do everything like that. I know I'm boring you with admin stuff, but just to explain to you why we weren't clearer since the start about the form of the exam. So we had to withhold a little bit, see where things were going. And then we figured, well, we can actually book these rooms. We have enough space. Let's have an invigilated in-person exam. However, we do realize that announcing it later in the term, like we did, was probably something that was less than ideal. I didn't expect this, but many students were potentially traveling during the exam period. And because historically Econ 1 101 had an online Moodle exam in the last few terms, I think people just assumed, well, it's gonna be as usual. And unfortunately, this is right the term where we wanted to change things. Also in part based on your feedback, but when we got emails saying, look, we had other plans, this is a big change that you're doing, you should have announced that sooner at the beginning of the term. I agree with you, and I realized this had created more trouble than I initially envisioned. So, long story short, keeping this all into consideration, we decided for T3 to stay with the online exam format that we used in T1 and T2. So let me say this again. We are gonna have an online exam in Moodle. You can be anywhere in the world, take this exam from any place you want. It's gonna be same as T1 and T2, which means it's a multiple choice question exam. There are no short answer questions, multiple choice as usual. Of course, I know that someone is gonna be happy, someone is gonna be upset, but to be fair, we have to give people enough advance, and this was something that took us a little bit of extra time to confirm from an organizational point of view. In any case, I hope overall people are okay with this. Thank you for your feedback. Thank you for letting us know immediately your situation. We need that, otherwise we cannot do our jobs. So how are you doing? How are they doing? How is everything going? Welcome to week 2. Please tell me what you think about this online exam. Just doing a little bit of survey. Would you have preferred an online exam or an in-person exam? What is your favorite? I'm gonna very soon jump into the course. This time I'm gonna try to be a little more careful, try to make sure that I'm not losing anyone so we can continue to engage online. But before we do that, I just wanted to say thank you for an amazing participation in your ebook. I'm seeing a lot of short answer questions submitted, very thoughtful markings and comments. Is great. Thank you so much for being an amazing cohort. Really means a lot to us, to the team, to see everybody putting their effort in, and also be kind and nice to your colleagues. Amazing. Thank you very much. You are the best. So the format will be multiple choice questions online in Moodle, just like previous terms. By the way, I should have said that I also posted an announcement in Moodle. So check my announcement in Moodle. It has a lot more details and more details to come, okay? But for now, it's a multiple choice question exam, and it's just like previous terms, it may have some numerical questions as well. And it's gonna be on Moodle during the exam period. We don't know the dates yet, so stay tuned for more information. But if you want to refer to the experience of your colleagues from previous terms, it's exactly the same. Multiple choice questions, no short answer questions, but as I said, numerical questions possibly as well. So questions where you have to input a number, for example. So you need to do a calculation and input a number. And otherwise multiple choice questions. I hope this is helping people. Let me jump into the content. In the meantime, Trent might answer some of your questions. Thanks so much for being such a lively audience. Really appreciate it. Chapter 2, the productive side of the market. Let's take a look at that. Quick recap of what we said in our last class. We have various type of markets, online markets, real life markets, but what we really use as a concept to define what a market is just people. People who buy and sell, the set of them, that's a market. That's what we care about. We're gonna always look at people. That's what economics is about. We also talked about equilibrium. Market equilibrium happens when the price is stable and the quantity demanded is equal to the quantity supplied. That's the definition. Many markets are in equilibrium. Then we talked about the favorite market for economists, the dream market, which is the perfectly competitive market. Like for example, agricultural products, farming, they kind of approximate a perfectly competitive market. But here are the characteristics. First, buyers and sellers, they cannot make the price. They have to take their price as given. They cannot affect the price of the goods they buy, and they cannot really stretch their price much. They need to take the prevailing market price and go with it. Like again, agricultural products are a bit like that. Also, these goods, by definition in this very abstract model, are all the same. Everybody's selling the same good, there are no differences. There is no external benefit and there is no external cost. In other words, when people consume a good or produce a good, there is no benefit or cost that is imposed on other people external to the market. So the only people that incur the cost and the benefit are the producers and the consumers in this market. But consuming and producing doesn't create an external cost. Do you want a counterexample? Pollution, climate change is an example of markets where the production of a good by polluting the planet affects all of us. All of us. We have nothing to do with producing or purchasing that good, but we still have to suffer the consequence of climate change. That's a huge externality, a real threat for society. But when we think about perfectly competitive markets, well, that's not something we are going to consider. In those markets, there are no externalities. Goods are excludable and rivalrous in this market. Goods like this can of a not well-defined product. This can is excludable, it's mine. If you try to steal it, I'm gonna call the campus police. And it's a rival. Let me see if it's really rival. Delicious. Now that I drank that, you cannot drink this. It's gone, it's in my stomach. So that's rivalrous. If I consume, you cannot consume. If you think about, well, all products are rivalrous, well, not really. Think about really cool stuff like fireworks in Sydney at the end of the year, but also more profoundly things like ideas, knowledge. Well, they're not necessarily rivalrous, right? And they may not be excludable. If someone posts something on the internet, a great idea, it might just go everywhere and benefit a lot of people at once and may not be excludable to people. Anyone with an internet access can get it. So yes, there are subtleties here, But in a perfectly competitive market, we are going to assume that goods are, in fact, non-excludable and rivalrous, just like this product, little product here. Notice how smoothly I managed to get a drink while weaving that into the educational content. The other thing is that in this market, we're going to assume there is full information and free entry and exit. The whole thing here is that if we have a perfectly competitive market, you don't need economics. You don't even need economists. You don't need governments. You don't need anything. Everybody would be doing what's best for them very selfishly and not only achieve the best outcome for themselves, but also for the community at large. So that's why the perfectly competitive market is such a great starting point. It doesn't exist. There is almost no real example of perfectly competitive market in the world, but it's a great benchmark to have. If the markets look like that, they will be so much easier to deal with. But during this subject, during this course, of course, we are going to take out some of these assumptions and make them more realistic. We also talked about this new model, and this is Steph. And as promised, I'm not gonna shuffle models around too much. We're gonna keep one unique model, foundational for everything that we do. So no surprises, no sleight of hand. This is just different because Steph, in fact, can produce fish instead of bananas and rabbit, or can harvest bushels of apples. And there is a slight change in the production function, but otherwise it's the same logic. And we're gonna use the opportunity cost theory, all these theories again in this chapter. Nothing gets lost, we just build upon it. What we said last time is that we are interested in thinking at the margin. Instead of thinking about big decision, I want to produce 30 bushels of apples or catch 60 fish. No, instead we are going to ask Steph to make marginal decisions, small decisions. Do you want to produce the first bushel or not? And only after they say yes or no, we ask, how about the second bushel? We break this down into small fractional decisions. Now, this is the table we're going to look into, and this is the example here. But I want to jump 1 second, then I'm going to show you, as usual, that everything that I do is following your slides, and I'm going to make sure to do a little recap on that. But for now, let's have a look at this table. And let me do this. I'm going to hide this part of the table because I think it's actually confusing. You can go back later on, take a look at it, and tell me if you missed it. Maybe you missed it in this particular level, but I think you won't. I think it's just confusing things a little bit. It doesn't really help. Now, in this particular model, Steph, he's interested in making as much money as possible. And they can produce apples or they can produce fish. And for each and every bushel of apple, they can get $1.9. They can sell that in the market for $1.9. They can also go and catch fish. And the price of fish is instead $0.50, 0.5, okay? Basically, we are looking at the same problem that we saw in the previous chapter with Ricardo's opportunity cost, but now we have the possibility of selling these things for a price. Nothing really changed substantially, but it's a good introduction to the idea of markets and exchange through currency. You do exactly what you used to do in Ricardo's model, but now we are introducing marginal decision making. So the question is, should you, Steph, produce the first unit, the first bushel of apple? Well, let's have a look at what happens if you do. If Steph produces the first bushel, they will spend 1 hour doing that, okay? So this is the cost in terms of hours. So I'm just gonna write down here, first bushel, it actually costs 1 hour of time. Of course, at this point, you know that economists are not big fans of just looking at absolute cost. hours. They want to know what Steph is giving up, not just the amount of time. Hard to say if 1 hour is a lot or a little, if it's precious time or not, unless you know what you would have done during that time. And of course, because we have only two options here, it's very simple to see that in that 1 hour, Steph could have in fact produced 2 fish. You know, it would have taken Steph half an hour to produce each fish. So a total of 1 hour for 2 fish. That is what Steph is foregoing. Steph is foregoing 2 fish. That being said, one extra layer here, we need to transform these 2 fish into dollars, because as we said, what Steph really cares about at this point is not eating this stuff. Steph is interested in selling it. So 2 fish, well, $0.5 per fish. That's the price. You can see it here. That's the assumption in the model. That's just the price that I came up out of my head, out of the top of my head, just as an example. And yeah, if of course 2 fish for a total of $1, and this is the opportunity cost. This is the smart way of calculating costs. Forget about the amount of hours. I don't know exactly what that means. Instead, let me go from the hours to what I'm sacrificing the fish, what that would have meant in dollars, and this is my marginal cost. I'm calling it marginal cost at the margin because, remember, we are making this marginal decision. We are saying, how about the first unit? So this is the extra cost of producing 1 extra bushel of apple. And I'm looking at the marginal time, the extra time that it takes to produce that unit, which is 1 hour. Now, all I'm left to do is compare the marginal cost with the marginal benefit. And where can I find the marginal benefit? The marginal benefit is here, right there. This is the marginal benefit of producing that bushel, which is the amount of money that Steph can make by actually selling it. So I'm gonna call this, I might actually call it properly so that we just fix that idea. This is the marginal benefit. So if you produce an extra bushel, you get an extra benefit, which is $1.9, the sell price, but you are gonna have to forego some fish, so that's your marginal cost. And in fact, if you do something like this, you do marginal benefit minus marginal cost, you obtain something like, in this case, you have marginal benefit, which is $1.9 minus the marginal cost. Oops, went the wrong way there. Let me move this super quick someplace else. So in fact, if you compute, you know, the marginal benefit minus marginal cost, you obtain 1.9 minus 1 gives you $1. Sorry, $0.9. Okay, I'm not doing a great job with these slides. So if you take the marginal benefit, 1.9 minus $1, the difference is $0.9, and that's what we call in economics the surplus, the economic surplus. So the difference between the marginal benefit and the marginal cost is what we call in economics the economic surplus. Economic surplus. Promise I'm gonna center my screen a little bit more in a second. So this is the economic surplus from producing the first bushel of apple, the difference between marginal benefit and marginal cost. And this is telling you essentially how much you like this choice relative to the alternative. If the marginal benefit is really big, then the economic surplus is gonna be big because you really like the idea of producing 1 bushel relative to the alternative of producing 1 fish. Of course, you can also do, so I'm gonna take all this stuff and I'm gonna make it a lot smaller, and I'm gonna move it around a bit to this part of the screen. And there you have it. So of course we could do the same thing for the second bushel. The second bushel, so let's do it quickly. I'm pretty sure you're getting this, but just safe than sorry. The second question is, well, the first one we answered, and it is yes, I want to produce the first bushel. How about the second bushel? Well, the second bushel is actually costing you a little bit more. This is a slight change relative to the previous model. You can see here that it takes Steph 1 hour and a half to produce the second bushel. Steph is getting tired, so the cost is increasing. The first bushel only 1 hour, the second bushel 1 hour and a half. Now, keeping this in mind, let's see what is Steph really sacrificing in that hour and a half. You can take a look at the fish here, half an hour for a fish constant. So in 1 hour and a half, Steph could have produced 3 fish. So the cost is foregoing 3 fish. So that's what Steph is using to understand what is the best alternative. So that's the opportunity cost. And we transform that into dollars. So this is 0.5 plus 0.5 for the second fish plus 0.5 for the third fish. And that's it. That's $1.5. How do we know whether we want to produce that or not? Well, we compare this, which is the marginal cost. From now on, I'm just gonna call this MC, and it will stand for marginal cost. You can also think of this as the opportunity cost, but because we are making marginal decision making, we are definitely gonna call it marginal cost. But in general, the marginal cost is always derived as opportunity cost, the value of what you're giving up. So compare the marginal cost with the marginal benefit, which is up here, marginal benefit. Still, the marginal benefit 1.9 is greater than the marginal cost. So the idea is, well, let's go for that second bushel here. Let's say yes to the second bushel. How about the third one? Well, this is an interesting one. The third one will cost you 2 hours. The cost is increasing. Steph is getting more and more tired. In those 2 hours, Steph could have actually caught 4 fish. So this is the really thing that Steph is foregoing, a fish that they could have caught if they hadn't produced the third bushel. And I think it's pretty easy to see at this point that if you are foregoing 4 fish, you're kind of foregoing $2. So your marginal cost is now $2. And unfortunately, you can see it here. At this point, the marginal cost is actually greater than the marginal benefit. $2 is greater than 1.9. So Steph does not want to produce the third. It's a no to the third units, and no also to all the other units. Because, you know, if you don't like the third one, then the other ones are just getting more and more expensive. So definitely you don't want to produce any other unit beyond the third one. Okay, and now let me actually put this in a graph so that you can see what I'm doing from a slightly different angle. So let me put the quantity of apple here. So this is the quantity of bushels, if you want. Let me just write apples, quantity of apples. And here we have the price in terms of dollars per apple. Okay, so dollars per apple, quantity of apples. Remember, in this simple exercise, the price was 1.9 for a bushel of apple. So we're just going to put that into the graph, the 1.9. So this is 1.9. The market price for, I can do a little bit of a better job here. So 1.9 is the price of an apple. And at this price, we know that the optimal amount for Steph was 2 units. So that's what I'm going to do. That's what I'm going to show in this graph. I'm going to put the price there, and we have 1 and 2 units. So I'm going to take this point. So this graph is telling you the following. Start from the price of a bushel, check on this graph, touch the point here, and go down. And what you find on the x-axis is actually the quantity supplied for Steph. When I say quantity supplied, is a specific terminology. Quantity supplied means the quantity that maximizes supplied. It's the quantity that maximizes Steph profit. So it's not any quantity that they could produce. It's the quantity that they want to produce if they are trying to maximize their profit, maximize the money that they can make. So remember, start from the price, check on this graph and find the quantity demanded on the x-axis. Of course, you could change this around. For example, ask yourself, well, how about I do the same exercise, but instead of 1.9, let's imagine that the price is $1. So somewhere down here, $1 instead of 1.9. Okay, well, if you redo the marginal analysis, you might find a different answer. For example, it might be a point here. You could also, try the same exercise, pick a higher price, $3 or something like that. And then you can essentially interrogate the model, figure out what is the optimal amount of bushels for Steph at this price, and you may find another point here. If you then connect all these points, you have just created a supply curve. So a supply curve, by definition, captures the relationship between a price in the market, for example, how much Steph can sell a bushel of apples for, and the quantity supplied, the quantity that Steph wants to produce to maximize their profits, to make as much money as possible out of the sale. So this is supply curve. You've probably seen it in high school. You have kind of seen that upward sloping supply curve. Now you know how we derive it. We start with simple productivities and we can derive the supply curve. It tells you for each price what is the quantity that the supplier wants to supply if their objective is to maximize profit. Now I'm gonna let you into a secret. Economists are sometimes a bit, they feel a bit of a sense of inferiority. And so they came up with this idea that there is a law of supply. They almost selling it to you as a universal law of human behavior. Just like in hard sciences, we have laws in economics as well. That's what I think the insecurity comes in. It was maybe in the 50s when people had this idea, we want to be a hard science. Economists wanted to be like hard scientists. So they came up with the idea that the fact that the supply curve is upward sloping like this, it goes up, which simply means that if people are, getting a higher price in the market, they will tend to supply more. So this upward sloping supply curve, they call it a law of supply. The higher the price, the more people are willing to produce that good. But it's a tendency. This is true. It's not always true. It's not really a hard law like some other laws in sciences. It's not a universal law, but that's what economists call it. And now, as always, I promised you that I would show you all the slides, all the things that we have done, and prove to you that we have not missed anything. Well, first of all, we looked at this table and we were just creating that cost-benefit type of analysis, suggesting that you need to calculate the marginal benefit for something, compare it with the marginal cost of something, and then take the action if the marginal benefit is greater or equal. This is our convention, greater or equal. But on the other hand, if you calculate the marginal benefit of, say, producing a bushel of apples, compare it with the marginal cost, and you find that the marginal benefit is strictly less than the marginal cost, then don't take the action. And this is what we just showed for Steph. Take one decision at a time, compare the marginal cost and the marginal benefit. Marginal benefit is really just the extra benefit that you gain from producing the extra unit, and the marginal cost is, on the other hand, the extra cost of producing that unit. Importantly, we are always thinking about opportunity cost. I'm not even going to say opportunity cost anymore, because in economics, the only cost that we care about is the opportunity cost. So in this case, we call marginal cost the extra cost of producing that unit. You could call it the extra opportunity cost if you want to add that word in there. Now we talk about the cost-benefit principle, which is how you decide whether to take an action or not by comparing the marginal benefit and the marginal cost. We also introduced the idea of economic surplus, the difference between marginal benefit and marginal cost. Yes, maybe the marginal benefit is greater than the marginal cost, and so cost-benefit analysis, you want to do that. But how bigger is the marginal benefit relative to the marginal cost? The economic surplus gives you an idea of what that is. And all those lines just summarized into one derivation here, hopefully clear enough. We talked about the quantity supplied, and we said this is a special quantity, not any quantity, but it's actually the quantity that maximizes the profit of the supplier. So just the quantity that makes the profit maximum. Just a quick aside, if you use marginal decision making, cost benefit, compare marginal benefit, marginal cost, next decision, marginal benefit, marginal cost, next decision. If you go on like this, you will mechanically, mathematically find the maximum amount of money for Steph. If you do step by step, you're gonna maximize the profit. You can check if the values that I suggested before using cost benefit are in fact maximizing profit for Steph, and you're gonna see that they will. Very well, then we have this idea of supply curve, which is the relationship between the price of a good and the service. And this is the graph that my graph was much worse than this. But remember, in this example, we started from $1.9 for a bushel of apples. These are bushels of apples per day. This is a nicely annotated graph with nice labels. So we said that starting from here, you can check on the supply curve, and the answer is you want to produce 2 units. Well, if you try different price, $1 would suggest you should produce 1 unit. If you tried with a different market price of $3, suppose the market price of bushels of apples is $3, well, then you would check on the supply curve graph, touch the supply curve graph, then go down here, and you would find here the quantity supplied, how much that producer wants to produce if they want to maximize profit. This is essentially becoming a staircase graph like this. The more numbers you try to put in, the more it's going to become like something like this. And the reason why it's a staircase graph and not a beautiful, smooth supply graph like this, like the one I showed you, is just because in this model, the only choice for Steph was to go from 0 units to 1 unit, then jump from 1 to 2, 2 to 3, but there was never a possibility, for example, for Steph to produce 1.678 units, bushels of apples. That was not possible by definition. But if you allow for fractional small amounts, then you would end up with a supply curve that looks like a straight line, potentially, that looks like this, continuous and smooth. Very well, everyone. I also touched, embarrassingly, I made a confession to you that economists have a bit of an inferiority sense, talking about the law of supply, which is the tendency for a producer to offer more of a certain good or service when the price goes up. And this is just captured by the idea that the supply curve is upward sloping. The more you increase the price, the more people want to produce, upward slowing. But it's not really a law, don't tell anyone, but this is just a tendency, okay? This is what we observe mostly in the real world. Fantastic. We also talked about the horizontal interpretation of the supply curve. Said it many times, but let me say it again. If this is your supply curve, find a price that you like, say $1, pick it, check on the supply curve, and what you're gonna find, so go touch the supply curve, then go down here. What you're gonna find is the quantity supplied or the optimal quantity that maximizes the profit for a producer. And I'm gonna talk about the vertical interpretation in a second. Now, this is the moment where we have covered everything I've done in that little graph. So I'm kind of taking a breather, taking a moment to have a look at the comment section to see if you have any question. But also, I'm sorry to bother you again, but I just want to know how we are doing here and how are you doing? Cannot quite tell from this camera angle. Would just like to know if the speed is good, too slow, too fast. If you can just give me a brief feedback on the speed. If you remember last class, we were going a little bit too fast, maybe at times. I just want to make sure that what I've done right now is perfectly understood and it makes sense. Please let me know. I'm also gonna check to see if anyone tagged me, and I can see that Ariane here tagged me asking, why is it greater than or equal and not greater than only? Remember, we were talking about the cost-benefit principle. I'm gonna make this small decision by comparing the marginal benefit, the extra benefit of that little decision with the extra cost. And we said, if the marginal benefit is greater or equal than the marginal cost, then take the action. But that's a fair point that has been asked here, because why would we take that action if the marginal benefit is exactly equal to the marginal cost? Fair question. That is a situation when they are equal, when effectively people would be indifferent between one action, taking the action or not. And this is just a convention. So if someone is indifferent, we don't quite know whether they're going to take the action or not. It doesn't really matter which action you take because they're equally as good. So in that case, we don't know exactly how people will choose, but just as an assumption for your exercises, for the assessments, for the final exam, just assume that if they're equal, as a convention, they are going to take that action, and nobody will ever going to take points away from you. So Kellen here saying maybe a little bit slower, and also Varia says a little bit too fast. Okay, so I'm getting a sense here that the consensus is that I should go a little bit slower from the messages that I'm receiving. First of all, thank you so much for letting me know. It's so cool that we can communicate even if this is like a YouTube stream. And I promise I'm gonna go a little bit slower in the next part of this class, okay? I also want to do exactly what we did last week. If you have time, right after I finish the class, maybe 10 minutes before the hour, we can use those 10 minutes for you to ask me questions, and I can literally redo that content for you. Very happy to do it. So instead of worrying too much about what you didn't get before, let's move on with the class. But then at the end, feel free to ask me questions, and I'm gonna, do the annotation that works, right? So we can be all on the same page. I think things are going well. I got tagged a couple of times, but I think Trent is doing everything right here in terms of moderating this. Trent, let me know if there is anything you want me to cover. I know that you had a lot of questions at the beginning. I think it was about the exam. I'm just gonna go quickly on, but let me know if there is something that I should know, or maybe I should spend a little bit more time talking about that. Cheers. Nice. Okay. So let's look at the situation where we want to derive the supply curve. But in this particular example here, we are going to look at a situation that resembles more what a company would be facing as a decision. Instead of a single individual like Steph, let's think about a company producing something. Okay, so I'm going to put a graph here. We're going to do a lot with this graph. It's going to be really cool. We're going to cover so many slides just with a single graph. Lovely. So here we are going to have the quantity of this product. So this is going to be quantity. If you want to label this really well, we're going to say units of this good. It could be anything. It could be soda cans, given that I'm drinking right now. Units per day. We always want to put like a time frame here. So it's quantity, units, not just units, but units per day. And then the price up here. So this price is instead dollars per day, per unit, okay? So this is how much money you can make for each unit that you're selling. Dollars, how much money you make for each unit that you are selling. Very well, so that's the graph that we're gonna do. We're gonna introduce now a bit of a different idea. We are gonna say that in this example, you need to pay $100, sorry, this is actually not minus, so this is our fixed cost, so $100. You have to pay the bank in this example, so it's what we call a fixed cost. So you have to pay the bank $100 no matter what you do, okay? So this is in economics called a fixed cost because it doesn't matter how much you produce in a day, you still need to pay the same fixed cost. So for example, suppose you produce 0. Well, the fixed cost is $100. Suppose you produce 1 unit. Oh, still 100. Suppose you produce 1 billion gazillion units, an infinite amount, still $100. One way to think about a cost like this is to think that the company is actually purchasing a fixed factor of production. Say, for example, a machinery where you put your soda cans and it just does its job of putting the liquid inside or things like that. So this is the fixed factor of production. It's a fixed cost. You can think of this as a loan, for example. You go out there and you need to buy that machine. So you go to the bank and you say, well, I don't have the cash to buy the machine, but I'm going to get a loan from the bank. And the bank is telling you, absolutely, we love your business, but you're going to have to pay us $100 every day, no matter what you do. Do 0, you do a lot, you do a medium amount of production, it doesn't matter to us, you still need to repay your loan. This is also what in economics we call a sunk cost, sunk. The reason why this is a sunk cost, this is a K, sunk cost. This is a sunk cost because it's in the past, it's a decision you made, you signed the loan with the bank, right? You signed the loan, you agree to pay $100 every day, and that is a sunk cost because at this point, after signing the contract, you cannot change your commitments. We are assuming that you cannot immediately file for bankruptcy or renegotiate your loan. None of that is available. You signed that contract, now you are stuck into this. You're going to have to pay $100 all the time. So it's a fixed cost because it does not vary with your production, and it's also sunk because you cannot change it no matter what you do. So this is the idea of a fixed cost, which we didn't see before, okay? This is kind of a new idea that maybe is more realistic for things like situations like companies having to make big investments to produce. This is fixed cost. Could I ask now super quickly, Kellen and Varia, if my speed now is better? I'm trying to go a little bit slower. I hope I am. But I can go even even slower than this. If you could let me know if this is a good speed, I'll keep going at this speed. Very well. Now moving on to the fun part. Well, not really, but I'm gonna tell you in a second why we need these models. And it's not to train you to be an entrepreneur. We want a model for society to actually see if our society is doing well or we could improve it. So bear with me, this is kind of important stuff. In this model, we are gonna assume that you can also hire workers to actually do the production. So the first worker, it's here, and they can produce, if you hire them, they will produce for you 40 units. So that's what they can do for you. They produce 40 units of this good. Of course, you have to pay them a wage. Okay, so what is this about? You need to pay them a wage to come and work for you for a day. And in this exercise, we're just gonna assume that the wage is $12. So they produce 40 units. They cost you $12 in wages. What we want to do next, remember, I'm gonna write down marginal cost as MC, just for simplicity. So this is marginal cost, MC. So the marginal cost here, because we are talking about dollars, we don't really need to worry too much about the opportunity cost in this example here, in this specific company example. So that's not the difficult part. But remember, we are talking about marginal. We want to see small decisions one at a time. So we are going to want to take the wage that we need to pay to this worker, but divide that by the amount of units that they are producing. So this is the wage, what we're paying. But we want to divide that by the amount they are producing. By doing that, we can get to the exact cost per unit, per soda can that is produced. So 0.3 is the marginal cost for each soda can when you hire the first worker. So it's the marginal cost for each soda can for the first worker. I'm repeating myself a little bit, but this is really important. And this is what we call our marginal cost. So this is the first step. We derive the marginal cost as the extra cost of hiring the first worker, producing 40 units, and we want to check what this cost is for each individual unit. It's 0.3 at this point. Yes, thank you. It looks like Kellen and Varia, they are happy with the speed, so that's awesome. I'm making progress here. Really good. Now, let's put this into the graph so we can tie the cost-benefit analysis to the graph in a way that I think will feel very natural, very natural. But you have to follow what I'm saying next, because if you miss this one, that's problem, okay? Now, remember that we have here the quantity units per day of these soda cans that I'm producing. And remember, my choice is either to hire 0 workers or to hire the first worker for this company. So the first worker, remember, is producing 40 units, right? 40 units. So if I hire the first worker, which is my first decision, marginal decision, they are gonna give me 40 extra units. So on the x-axis, I have 40 units here. And then what I want to do is the following. I want to find out what is the price at which I can sell this good in the market. And imagine this is, again, follow me here because this might get confusing otherwise. I am just gonna say here that the this is the price, so $1.2. This is the market price, okay? So this is just something, I'm not deriving this. This is just what the exercise will give you as a number. So the exercise will tell you, you can sell these soda cans, each soda can you can sell for this price. And this is because some reason, the market price has converged to this. and so on and so forth. So when it comes to this marginal decision making, your marginal benefit is how much money you can make by selling your soda cans. So in this case, the marginal benefit is in fact equal, marginal benefit is equal to the price that you are selling this good at, which is equal to, so this is marginal benefit equal to the price at which you're selling at, which is $1.2. So in this example, the marginal benefit is given by this point here, and the marginal benefit in this case is the amount of money you make when you sell each soda can. It's 1.2. Now, what we need to do is compare this with this item here, the marginal cost, right? We want to do the cost-benefit analysis, so we want to compare the marginal benefit of something with the marginal cost. I'm gonna draw this 0.3 here, 0.3 in the same graph. I now have my market price, and I also have my marginal cost. And I'm gonna draw it in this particular point here. So we have on the one hand our marginal revenue up there and our marginal cost here. Now in terms of cost-benefit analysis, this is the perfect way to think about that. So marginal decision making, remember the question is, should I hire the first worker? Should I hire the first worker? Should I? Well, this first worker is going to give me 40 units, and I can sell each unit at this market price, $1.2, which is my marginal benefit. But I am going to incurring a cost equal to $0.3, which is calculated like this. So down here. Of course, because the marginal benefit is actually greater than the marginal cost, then the marginal decision making is suggesting us to hire that first worker. Yes, we should hire the first worker because the marginal benefit is actually greater than the marginal cost, and the difference between the two is your economic surplus. Okay, so here we have it. We calculated the marginal cost by dividing the wage by the amount of soda cans that the worker produces. We know the marginal benefit, which is the amount of dollars I can charge for each and every soda can. So I have the marginal benefit of the soda can, I have the marginal cost of the soda can, the difference is the surplus. In this case, the marginal benefit is greater than the marginal cost, so I should take this action. I should answer this question, yes, I do want to hire that first worker. That's what I want to do. So I'm gonna just clean this up a little bit now, but you know, so that we just leave those 2 points, the marginal cost point and the marginal benefit, in the graph, because that's what really we need, right? So we just need to look at that red point and that blue point there. So I'm gonna delete this for a second. I'm just gonna simplify it to make this a little more readable. So this is our marginal benefit point. And down here at 0.3, we have our marginal cost. Marginal cost. Okay, so far so good. Now, let me ask the second question. So the first marginal decision was, should I hire the first worker? But how about the second worker? The second worker, should I hire them? Well, remember, all these numbers, they're just coming from your example in the slides. So we are assuming in the slides, in this particular exercise, that the second person will provide you with 50 units, okay? So actually the second worker is more efficient. Maybe because it's good to have a co-worker, so when the second co-worker comes in, they can learn on the job, maybe they can chat and troubleshoot. For some reason, this is just an example, just a numerical exercise, but we are assuming in here that the second worker gives you 50 units. They also have the same cost in terms of wage, is $12, so they cost you the same. So if you calculate here, so I'm gonna just make that a little bit smaller so I can fit this stuff. So the marginal cost of this person is, again, their wage, which has not changed, divided by how many units they're producing, which is 50. So we took the amount that they produce, and we did wage divided by that amount, and that gives us 0.24 dollars. So this is the marginal cost. Remember, we are talking about marginal cost. The marginal cost of hiring the second worker in terms of how much each soda can is gonna cost us. In the graph, remember, this is the tricky part. You want to now add the production that the second person is gonna bring in, which is extra 50, which is giving you a total of 90. So if you hire 2 people, you are going to, get 90 units, because it's the first worker 40 plus the second worker 50. That's where some students are like, hey, I didn't catch that. But hopefully today I am actually making myself clear. And the marginal cost we said was 0.24 for the second worker, which means that the marginal cost is actually lower. So this marginal cost was 0.3, a little bit higher, and this second one is lower. But let's look at the marginal benefit in the same graph. Well, the marginal benefit is constant, right? Because this is the amount of money you make for every single soda can that you sell, and that has not changed. You can still charge the same amount for every soda can that you sell, and this is the surplus. The surplus is getting even bigger, so I would say yes, we want to hire the second worker as well. Brilliant. Now, this can become a little repetitive, so I might go a little bit faster now. Stay with me, but I'm trying to go a little bit faster. So the third one, the third worker, and my handwriting is gonna get worse as I do this. The third worker, we are gonna assume that they can produce 30 extra units, okay? And that the wage is always $12, you pay them all the same, and the marginal cost in this case becomes 12 divided by how much they give you extra, which is $30, which gives us a marginal cost of 0.4. So I went a little bit faster, but I've done the same thing as before. Now you may wonder, why did you decide to, in this example, which is just a purely arbitrary example, to set those at 30 units? Well, the general rule in real life, it's not always true, but it's kind of realistic. If you have a conveyor belt, a big machinery, and then the first person can operate the machinery really well, maybe if you add a coworker, as in this example, they might be even more efficient. They can take the machinery from both sides or something like that. But if you add a third person, they might start butting heads. They're getting in each other's way. There's not about enough space to operate this machinery, and if we add even more people, they're going to start fighting with each other for access to the machine. Think of you are an office worker, and you have only one computer and 10 people that needs to send an email, and you all fight for that piece of machinery. The idea is that for a given amount of technology or machinery or fixed factor of production that you loan to the bank, the more you add personnel to it, you're probably going to get eventually a decreasing productivity, and it's captured here. So the marginal cost of this person here is actually going up to 0.4, as we just saw a second ago. So if I had to graph this would be a little bit higher than our first worker. So we need to add now 30 units, so it's gonna be 120 here. And the marginal cost is now 0.4, which is a little bit higher than even before. The marginal benefit stays the same. You keep selling your stuff as much as you want, always at that price. So the surplus is still positive. So yes to the third worker, but you can see what's happening here. It's actually shrinking. The marginal cost is coming back up, and the marginal benefit is going down. So if you go to the fourth worker, well, you will see that that will only produce, in this example, I keep saying it, this is just an example, but it will only be able to produce 10 units. The wage is $12, so you're gonna do marginal cost equal $12 divided by 10 units they produce, 1.2. And I think you see what I see. The marginal cost is now equal to the marginal benefit. So for this particular worker, we get 230 with the additional 10 units they provide. These guys are providing less and less. The marginal cost is here. The marginal benefit is overlapping, staying there. So there is actually zero surplus. We are at the point where we are not really caring too much about this extra worker. But as we said, when we are indifferent, we go for it. Just a convention for this course. So we say yes to the fourth worker, but we are definitely not going to say yes to the next one. And if you look at the exercise, you are going to see that if we do the same calculation for the fifth one, it's going to produce even less. So the marginal cost is going to be up here. Your marginal benefit is going to be down here. So it's going to be even less increasing, and the marginal benefit is here. So this is actually a negative surplus because the marginal cost is greater than the marginal benefit. And that's the story behind all of this. So the supply curve in this case is given by this line. But before we talk about that, I'm just going to go through the slides and reassure everybody that I have covered basically your slides. We talked about the fixed factor of production, that machinery, and the fixed cost associated with that. We also talked about the variable factors of production, the workers. This one, I'm going to talk about this in just 1 second. So short run, long run. And what I did in that graph is basically what you have in this table. Instead of hitting you with these numbers like that, I showed you the graph. And then we did thinking at the margin. We decided, should I hire the first worker or not? That was the question. And we would calculate the marginal cost, 0.3, compare it with the marginal benefit, and make our decisions. And at this point, I need to have another insert here of an empty slide, because this is the new stuff that I'm going to do next. Before I venture into that, though, a little break for me to get a sip of water. Water. You know what I mean? The good water. But I'm going to keep an eye on the chat, see if anybody has a question. I don't see my name popping up, which is really good. I hope the speed is good. But if you want me to slow down, just raise your hand back there, send me a message, and I'll do. For now, it seems everything is going well, so all good. Jumping back into the next part of the class, where I need to introduce the idea of profit. So what is profit? Super simple, but I want to formally explain this. So we are going to call profit with the letter, we're going to denote that with pi for profit, from the Greek P. And this is the total revenues that you make. Revenues here mean this: the amount of money you make by selling the soda can. So in order to calculate this, you need to have the market price, and that's the market price, and you multiply this by the quantity that you are supplying. So the optimal quantity, the quantity supplied. And then on this, we have to take away the total cost of production, what you're spending for production, which is given by two parts: the fixed cost, the loan to the bank, but also the variable cost, how much you pay for every worker, variable cost. Okay, getting these out of the way. These are profits. Total revenues minus total cost. Revenues is the price that you're charging for each soda can multiplied by how many soda cans you're getting. That's the total profit. And then we have the total cost, which is the fixed cost plus the variable cost. Now, one thing that I want to do now is show you that graph again that we just did. So here we're gonna have, I'm gonna try to be a good boy and actually write it well. Quantity, units of soda cans per day. That's how you do it. And then we're gonna have the price here again. So I'm kind of framing it for you again so that we know where we are. We are looking at the same graph as before. That graph was like dots, like this, right? And the reason was that you could only hire 1 worker or 2 workers or 3 workers, and you would basically jump from one quantity to the other. But what if you can hire people part-time so that you can hire people in any small quantity you want to produce exactly the amount of soda cans that you want? Well, if you could do that, we would move from points like this in a graph to actually a beautiful smooth line like this for your marginal cost, which would capture the idea that you can produce any fractional amount. And that's the type of graph that I'm going to use right now. Don't worry, there's going to be no need for calculus or taking derivatives. We're just going to use this graph visually, nothing else. Just understand the graph visually. Well, you may be thinking at this point, well, I think what Alberto just said, but it was really quick, so I couldn't even hear it, is that the marginal cost curve is the supply curve. And if you got that, you're kind of right, but not exactly right. And that's what I'm going to do in this particular drawing here. So it is the supply curve if you look at it this way. Suppose I come up completely fake. I just come up with the price. And I say, this is the market price, okay? That's how much I gain. Just a number that I am making up. So then I would go, touch my marginal cost curve, go down here, and this would indeed be, if I did that, so like horizontal interpretation of the supply curve, touch the marginal cost curve, go down, find the quantity, that would indeed be the quantity supplied, or the optimal quantity that someone should produce if their objective is to make as much money as possible. Start from the price in the market, check on the marginal cost curve. I promise you, this is the quantity that gets you as much money in your pocket as you can. And if you're wondering, wait, I forgot what the marginal analysis was for this. So, well, it's really simple, and it goes like this. Like, for example, should I produce this first unit here, right? So should I produce this little unit here? Well, this is the marginal cost. This is the marginal benefit, just like before. This is the surplus. I love it. I'm going to say yes. But then, can I produce a little bit more? Remember, I can produce any amount now, 1.0001 if I want, any small amount. So for this small amount, is the marginal benefit greater than the marginal cost? Oh yes, still greater. There is a surplus. I should go on. Should I produce a little bit more? Yes. The marginal benefit is greater than a little bit more. Yes, marginal benefit greater than marginal cost. All this area is surplus, economic surplus that you make by producing a little bit more. A little bit more, yes. A little bit more, should I go? Yes. There is a surplus to be had. Should I expand a little bit more? Marginal quantities? Yes. Marginal increase? Yes. But you see, at a certain point, your marginal cost goes up. So the extra units are becoming less profitable to you in terms of surplus, up to the point where the surplus is 0 here, and you stop. So this is to say, start from a price, run it over on the marginal cost, and this is the quantity supply. This is the best quantity for you to produce, because it's the quantity that maximizes your surplus. You make all these decisions where marginal cost is greater than marginal benefit up to this unit. When you get to this point, then you need to stop, because the surplus is not there anymore. That's when you stop. This is your stopping point. No more than that. If you go more than that, in fact, you get a negative surplus. The surplus would become negative. This wouldn't be a good thing for you anymore. This would actually be a negative surplus that you get if you continued, because the marginal cost is now greater than the marginal benefit. So this is why you may be thinking, okay, this is actually true. The marginal cost is the supply curve because literally it tells me the relationship between the price of a good and the quantity that a producer wants to supply if their objective is in fact to maximize profit. So why is Alberto wasting my time showing me this graph? Well, there is a caveat here. So this marginal cost analysis works, but you also need to check the profit of a firm. That's the long and short of it. We have to also additionally think about the profit. And in order to do that, I'm going to introduce two new concepts, and you're going to be like, why are you doing this, Alberto? Why are you introducing this? It's just confusing. It will make sense in a second. The average variable cost is defined as the variable cost of producing a certain amount of cans divided by the quantity that you are producing. So it's literally averaging out the variable cost. And the average total cost curve is actually given by the fixed cost plus your variable cost divided by the quantity. So it's like the average variable cost, so the variable cost divided by the quantity, but you are also considering here the fixed cost. So the average total cost includes both. Now, mathematically, absolutely trust me when I say this, this average variable cost and average total cost, they are by design going to look like this. So if you want to do this correctly in your exam, just do it exactly the way I did it. Average total cost is here, and the average variable cost is here. Of course, the average variable cost is lower than the average total cost because the average variable cost includes the fixed cost, excludes the fixed cost. Now, the important part in this graph is that you have to draw them such that the average total cost gently touch the marginal cost at the lowest point of the average total cost, and also same for average variable cost. So see, decreasing touches the marginal cost and increases. Similar, decreases, touches the marginal cost and it increases. This is a property of these curves, and it's always going to be like that. Imagine if we are sitting in a classroom, we are taking Econ 101, we are in a classroom, and the extra person that comes into the classroom, imagine is this marginal person here, is actually shorter than the average height person in Econ 101. Well, if the marginal is shorter than the average person in the room, what's going to happen to the average height in that room? Well, now that the shorter person got into the room, the average height is decreasing. And you can see that the average cost goes down. How about I introduce another person, a bit taller, but still shorter than the average? The average continues to go down in that room. What if I put another student in that's shorter? Well, it will continue to decrease the average. And there's going to be a magical point. If I keep picking taller students to get into the classroom, there's going to be a point where this student is actually exactly equal to the average. So at that point, the average total cost and the marginal cost must be the same. But then what if I continue to put in people that are slightly taller? Then at this point, the average must go up, right? And if I put another person in slightly taller, the average will go up again. So at this point, the average total cost must go up. This is not a perfect analogy, but just to explain to you that when you're talking about marginal extra cost and the average total cost, they need to meet at the lowest point in these two. It has to be for mathematical reason. There's no other way. It's a mistake if you don't do it. Now, the interesting thing about this is that we know that in this part of we can use this graph to immediately capture some super helpful little thing that will help you massively in the exam. So there is a special point here, which is this one. So if you see something like this, a price like this, which I'm gonna call the zero price. For a price like this, you find the optimal quantity on the marginal cost curve. It's down here. So this is the optimal quantity for the producer, right? But this is a special point because it's also where we are at the bottom of the average total cost. I can promise you, you can do this calculation. It's always going to be the case. You can count on it. The profit for the firm, when the price is this one here, is going to be zero profit. The firm will be charging this price, producing this much, and as a result make zero profit. That's the beauty of this graph. You know that if you show this graph and we're talking about this point, you know this price, you know that the firm is making zero profit. How about this other point here, this one? I'm gonna call it, it's another special price, I'm gonna call negative. So at this particular price, you're gonna find the quantity that the firm wants to produce in the on the marginal cost curve, just as usual. To find what is the quantity supplied, it's here. And at this point, the profits are gonna be exactly equal to, in our example, minus 100, which is to say, the profit is gonna be equal to minus the fixed cost of your production. And this will be true every single time. It's always gonna be true that at this point, your profit is gonna be zero, and it's always gonna be true that at this point, your profit is gonna be negative. You're gonna make a loss, and that loss is exactly gonna be equal to your fixed cost. And why is that important? Well, let's see if a firm, for example, would ever accept to a price here, for example, in between these two. Okay, imagine that the firm is happy at the beginning. The market has a great price here. It's a pretty high price, right? They go and they find the optimal quantity. At this point, the profit is actually positive, so the firm is making a positive profit. But as the price declines, imagine the price goes down, the company is going to move along the marginal cost curve down, and every time the firm is going to lose some profit. Of course, the price is low, getting lower, so less profit for the firm. Up to the point where we are going to get to this special intersection, where the profit has decreased to the point where it's equal to zero. If you continue to decrease down here, that's going to get you into negative profit. So this is going to be a negative profit, say minus 10. So if you are in the long run, if you can just exit the market and make $0, if you have no commitments with the bank, you are in a situation that economists call the long run. You are in the long run when you are a free person. You have no commitments. You can file for bankruptcy. You can stop paying the bank. In that case, your alternative is stepping out of the market and actually make $0. So in a situation like this, in the long run, of course, you wouldn't want at all to go beyond this point into negative profit. So your supply is going to trace the marginal cost, but up to this point. If the price gets lower, the answer is no, I don't want to continue to produce because I'm going to make negative profit. In other words, in this particular example, in the long run, the supply curve is equal to the marginal cost curve, but up to a point. It's equal to the marginal cost curve, but up to this point here when profit is zero. Below that, the firm will just exit the market. But how about the short run? So a period of time when you still have to pay the bank $100 no matter what. In the short run, you cannot file for bankruptcy. You have a fixed cost of production. You need to pay the bank $100. Well, in that case, a price like this one, right, which is relatively low, in the long run, you wouldn't want to produce this quantity at that price. But in the short run, when your hands are tied and you need to pay the bank no matter what, even if the option is producing a certain quantity, this quantity, and make a negative profit, that is actually better than the alternative, because yes, you're gonna lose $10, absolutely true, but your alternative would be to have to pay the bank your fixed cost. So the choice is, I lose $10 or I shut down production and I pay the bank anyway $100. I prefer to pay $10 rather than $100. So it's even sometimes when firms are making negative profit, it might still be possible in the short run to make sense for a firm to continue to produce. And this is true. So in the short run, the supply curve is gonna trace the marginal cost curve. It's even gonna go into negative territory right here. So in the short run, we are going to trace the marginal cost curve and still produce even here. But at this point, that's when we stop. Even in the short run, we have a stopping point. Because at this point, we are actually losing exactly the same amount as the fixed cost that I have to pay the bank. So I don't want to go any step further, because if I did, suppose the price continues to go down and I'm considering producing, but my loss at this point will be greater than minus 100, maybe it will be minus 110. And this is not something I want to do. I don't want to pay more than what I owe the bank. So in this situation, for a short run firm that has a commitment with the bank, just like we saw in the first example, then the supply curve traces the marginal cost curve up to this point where the average variable cost touches the marginal cost. Beyond that, the firm doesn't want to produce at all, so the supply curve stops there. Thank you so much for your patience. I have been slowing down a little bit in the attempt to make this more inclusive for everybody. So I've been running a little bit late, but I promise you I did everything I wanted to do today. And you can see here that in the slides, we are going to calculate the profit. Then the profit is defined as the difference between total revenues and total cost. We said that, okay, if you're making a positive profit and the alternative is to shut down but continue to pay the bank, definitely you want to produce. But even in situations where you're making a negative profit, for example, minus 88, but if this is better than the alternative, which is to pay the bank and keep paying $100, then you might want to continue to produce. And that's the shutdown condition in the short run. Produce as long as your profit is not getting any lower than your fixed cost. But in the long run, instead, you are a free bird. You can leave without any commitment to the bank, so you want to keep producing only up to the point where the profit is greater or equal to zero. And in fact, I show you that we can go from a discrete model like this to a smooth model where you can hire people in fractional amounts. And I described how the marginal cost curve can be used to trace the supply curve. So the part of the MC above the average variable cost in the short run, and the part of the MC above the average total cost. So if we go back here, basically the part of above the average total cost curve, this is the supply curve in the long run. In the short run, instead, the supply curve is a little bit longer and it goes up to the average variable cost. So we covered this, and that's all I wanted to do today. I will still remain available if you want to tag me for any question, but I literally have 1 minute away from 1 p.m. So I stretched this a little bit more than usual. I have done my own cost-benefit analysis. Should I slow down a little bit and get a little bit longer with this class? And I thought I would go for it because it was requested in the chat room. And after all, you are probably watching me at double speed if you are seeing the recording of this. So there's always that option, which I think makes a lot of sense. I'm not seeing myself being tagged anywhere here, and we have a really impressive amount of students still online, and for that I thank you. Thank you for putting up for the extended time today. I'm pretty sure you're gonna have to run to some place now, but in the meantime, I'll keep an eye on the questions in the chat room, so if there is anything that I can help with. But in the interest of time, I am going to wrap up this session as usually by saying thank you so much for coming. Thank you for helping me set the pace. If you want a certain pace, hundreds of other students will want that as well. So thank you for being a voice for other people as well. We are gonna see each other next week. I'm gonna introduce a colleague of mine, Esther, who is gonna cover some of the classes, but I'll still be around and come in and out and be around for the important things, the final exam and discuss things. I will keep sending announcements. I'll keep answering emails. I'm just gonna be one email away. Thank you so much for your time. Thank you, and also thank you for your messages now coming in. Really appreciate it. Have a phenomenal day. Honestly, I would be on the beach. This is too good. Sydney has been good to us. You may be somewhere else in the world though, and I hope that just as sunny as this place. Thank you so much for coming. A big thank you to Trent for helping me manage all the questions coming in. I just noticed a comment saying the Popeye shirt, yeah. Who's the boss? Who's the boss, right? That's it. I'm not sure I'm the boss, but I think this shirt is a good attempt at being the boss. Thanks so much, everyone. I wish you an amazing rest of the day. You see what I'm doing, right? I'm just buying time to see if there is any other question. But as promised, I'll be in the chat a little bit longer if anything pops in. Thank you so much for coming. Thank you for your patience. Tell everybody that the exam is online.